Okay, this is lesson 2 for probability, and this is on the multiplication rule for probability. Very important, this rule is for more than one trial, so when you're selecting objects or people, you need to make sure they're picking more than one. Because what I tell people in the classroom is that if you see the word and, that's your indication that you want to use the multiplication rule. Just like for or, it's the addition rule. However, sometimes you're going to see the word and you really wouldn't use the multiplication rule because you're only selecting one person or one object. I'm going to show you the difference in that during this video. First thing you want to check for is independence. Just like when you're using the addition principle, you look for whether or not two objects are mutually exclusive or inclusive. For multiplication rule, you look to see if they're independent or dependent. There is a key phrase that will help you with determining if two objects are independent, and that's the phrase with replacement. If they tell you it's with replacement, then each trial is independent of each other. If that's the case, then the way you find the probability of A and B is the probability of A times the probability of B. Okay, that's again with replacement. If the objects are dependent, okay, and that means without replacement, meaning you're not putting them back. So the next straw is dependent on what you got for the first straw. If that's the case, then the probability of A and B is the probability of A times the probability of B given A. So this brings in the conditional probability that we'll talk about too at the same time. So I'm going to show you how to do some that are independent and some that are dependent, so you can see both of these. Okay, for example, in the bag, we have a bag of goodies, as I like to say, and in that bag we have the following items. We have one white die, one orange, one grape cluster, one vehicle that floats or flies, that's purple. These are all purple items. Blue items, we have one blueberry cluster, one vehicle with wheels, and one blue die. For red, we have one strawberry, one vehicle with wheels, and one red die. For green, we have one apple, one green die, one vehicle with wheels, one vehicle that flies or floats, and one animal. For yellow, one banana, one yellow die, one vehicle with wheels, one vehicle that flies or floats, and one animal. This is what it's in my bag of goodies. Now I'll come back to this. I don't expect you to know all this. The example we're going to look at is, suppose that I want to randomly select one item from the bag, record it, and then return the item to the bag. Then you randomly select a second item from your bag and record it. This is called with replacement because you put the first item back. That tells you that these two trials are independent of each other. With that being the case, we're going to use that first rule, which is the probability of A times the probability of B. Alright, so the first thing you want to figure out is what we're going to do to answer these questions. Okay, here's the first question. What is the probability that the first item is red and the second item is blue? Well, again, we're talking about probability, so you should have fractions. And since we already know they're independent, we're going to do probability of A times the probability of B. So the first thing I'm going to do is figure out the probability of A. Well, in my bag, I need to first count up all the items that I have, because that's going to be my entire sample space, which is my denominator. And in this case, I have 20 items. So my two denominators, because I'm putting them back, are both going to be 20. That's the idea with replacement. Okay, then for the numerator here, my first event is the first item is red. So I'm going to come back to my little list, and I'm going to count up how many red items I have. Well, I have 1, 2, 3. Alright, so my red item is going to be 3 out of 20. I'm going to do the same thing with the blue, and you can just take my word for it. But with the blue, I also have 3 blue items. Alright, so this is going to give me a reduced fraction of 9/400. Okay, that is my probability. Most of the time they're going to ask you to use 3 significant digits. In this case, it's going to be 0.0225. So about a 2% chance that you're going to have this happen in this situation. Okay, that's an example of with replacement, which means that they're independent. And we're going to do a couple of these. All right, here's another question. Still going off the same idea that they're independent. All right, what is the probability that the first item is a die and the second item is a die? All right, well, again, we have 20 items in our bag. Since I'm putting it back, that's not going to change. All right, so I want to find out, I want to add up all the dies, and it doesn't specify a color, it just says a die. So I'm going to go back to my list and I want to count up all the dies. So let's do that. Alright, well, I've got a white die, so it's 1. A blue die, that's 2. A red die is 3. Green die is 4. And a yellow die is 5. So I have 5 dies. And since I'm putting it back after I draw it, in my second trial, I'll still have 5 tries, or 5 possibilities of pulling a die. So my reduced fraction this time is 1 out of 16, which is approximately 0.0625, rounded to 3 significant digits. Right, so that's that probability. And the last question that goes along with the idea of independence: what is the probability that the first item is a vehicle that flies or floats, and the second item is a banana? All right, once again, my denominators are 20. Okay, vehicles that fly, I'm going to count them up for you guys, and I've got 1, 2, 3. Okay, and the banana, I only have 1 banana, so it's just 1 out of 20. So this is going to be 3 out of 400, which is approximately 0.0075. Okay, so this is the idea of using the multiplication rule when the items are independent, or i.e. with replacement. Now what happens if they're not independent or they're dependent? Then what do? We're going to take the same question, same exact questions, and we're going to see what happens when you don't put the item back in the bag. Alright, so here's the example again, just to remind you what we were doing. So suppose you randomly select one item from your bag, record it and set it aside. Then you randomly select a second item from your bag and record it. Notice that you did not put the first one back. This is where the idea of that second probability comes into play. Now when you're doing this, this means that it is without replacement, which means that your trials are dependent of each other, which means when you go to pick that second one, something special happens, and we're going to talk about that in the next 3 questions. Now the questions are exactly the same as what we were just looking at. We're going to look at them from a different perspective. All right, here's the first one. What is the probability the first item is red and the second item is blue? All right, well, this is where it's going to get a little different. For the first item, I still have 20 items to choose from. But since I am not putting that object back, when I go to pick my second item, there are only 19 items in the bag. So my denominator is going to decrease depending on how many trials that I'm doing. As far as the numerator, since I'm picking different items, they're not going to change. Okay, so if the first item is red, that's still going to be 3. And second item being blue, well, remember we had 3 blue items too. Those are not going to change because they're different categories, and you'll see what I mean when we get into that. All right, my reduced fraction here is 9 out of 380, which is approximately 0.0237. 0.0237. So you can see the difference between this question with replacement and without replacement. The denominator is decreasing. Okay, the second question we looked at: what is the probability the first item is a die and the second item is a die? All right, the same situation with the denominator. It's going to decrease. Now here's where this question is even more different from the first. Because we're picking from the same group, i.e. we're picking a die the first time and a die the second time, not only will the denominator decrease, but the numerator will as well. So I had 5 dies to choose from, if you remember. Well, if I pick one, then when I go to draw again, there's only 4 in the bag. So both the numerator and the denominator are going to decrease because I'm picking from the same group or category. So my reduced fraction here is 1 out of 19, okay, which is approximately 0.0536. Excuse me, 26. 0.0526. So you can see the difference even with this question, with both numerator and denominator decreasing. And then finally, to wrap up this lesson, the last question we looked at: what is the probability the first item is a vehicle that flies or floats and the second item is a banana? Still going off the idea of without replacement. Okay, so our denominators still decrease, but again, we're picking from 2 different categories, So the numerators are going to stay the same as we had in the first example. So I had 3 vehicles that fly or float, and I had 1 banana. That's not going to change. Okay, so this is going to be 3 out of 380, which is approximately 0.00789. So this is the whole idea of the multiplication rule. Now what I wanted to show you is the difference in a certain type of question, how you know whether or not and always means multiplication. In this case, every time we saw and, notice just like in this question here, for example, was it probably that the first item is a vehicle that flies and, keyword being and, the second item is a banana. We're doing 2 different trials connected with the word and. That tells you multiplication rule. Now look at this question. You can read it. I'm going to read it to you guys anyway. Alright, this is called survey refusals. This is a pharmaceutical company is interested in opinions of the elderly because they are either receiving Medicaid or Medicare or will receive it soon. What is the probability that the selected subject is someone 60 and over who responded? So even though we don't see the word and here, oh yes you do, I'm sorry, here's the word and. Okay, it's someone who's 60 and over and they also responded. Okay, so you're looking at 2 different categories, but this is your key phrase. You are looking at 1 selected subject. So even though you're looking at that subject being in 2 categories, you're not doing 2 trials. So even though you see the word and here, this does not mean multiplication rule. This is where you look at overlapping and you really only have 1 probability that fits this. So we're not actually going to work this problem. I just kind of wanted to show you the difference in the wording. Okay, this concludes our lesson on multiplication rule. Lesson 3 will be coming up shortly.